In mathematics, a geometric sequence, also known as a geometric progression, is a sequence of numbers in which each term is equal to the previous term, multiplied by a constant value called the common ratio. The geometric sequence can be expressed in the form ar raised to power 2, ar raised to power 3, and so on, where a is the first term and r is the common ratio. To find the common ratio, denoted by r, of a geometric progression, you can divide any term in the sequence by the previous term. The result will be the same for any pair of consecutive terms. The common ratio is the current term divided by the previous term. If r, the common ratio, is greater than 1, the sequence will be increasing. If r is less than 1, the sequence will be decreasing. To find any term, which is the nth term of a geometric sequence, we use this formula. An equals ar raised to n minus 1, where n is the number of term we are looking for. The sum of the first n terms in a geometric sequence can be calculated using this formula. Sn equals to a times 1 minus r raised to power n divided by 1 minus r, where Hsn is the sum of the first n terms of the sequence, a is the first term, and r is the common ratio. Given the geometric progression 5, 10, 20, 40, 80, find the ninth term. The formula for finding the number of term is n equals to a times r raised to power n minus 1. A, which is the first term, is 5. R, which is the common ratio, can be second term over first term, third over second, and so on. And hen, the number of term, is 9. By substituting, we have 5 times 2 raised to power 9 minus 1, which is 5 times 2 raised to power 8. It equals to 5 times 256, which equals to 1280. So, the ninth term of the geometric progression is 1280. If nth term of the GP, 3, 6, 12, is 192, then what is the value of n? A, the first term, is 3. R, the common ratio, can be 6 divided by 3, 12 divided by 6, and so on. The common ratio is 2. 192 is the nth term. An equals a times r raised to power n minus 1. By substituting, we have 192 equals to 3 times 2 raised to power n minus 1. Divide both sides by 3. We have 64 equals to 2 raised to power n minus 1. We can express 64 as 2 raised to the power of 6. Since the bases of both sides of the equation are equal, we can equate their powers to have 6 equals to n minus 1. By collecting the like terms, we have n equals to 6 minus 1, which is equal to 5. So, the value of n is 5. Now try these on your own. What is the fifth term of the GP 3, 6, 12? A GP has 6 terms. If the third and fourth terms are 28 and negative 56, respectively, find the first term and the sum of the GP. You can pause the video to try it on your own. The answer to question 1 is 48. For question 2, the first term is 7, and the sum of the GP is negative 147. Smart myths, be the smartest.